If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue. Okay, so in this video we'll continue with the formal logic connectors for the conditional logic in the games. So, how is formal logic relevant in the games section? Now, statements may be joined by and or connectors. So what does it mean when a statement is joined by and or? And what does it mean when an and or statement and or statement is negated? Okay, so in terms of the basic connectors, you can have statements joined by and or. So for example, we've got simple game of the rules here. A, B, C, D are toys that go into boxes 1 and 2. So then it tells you, a rule tells you that A is in box 1 and B is in box 1. Now, and is very similar to the everyday meaning of the word and. So when two, or sometimes more, but usually just two. So when two elements are joined by and, they both have to be true in order for the combined statement to be true. So that's what connectors do. They take statements that are either true or false, and then depending on what the connector and or in this case does, lets you know whether or not the combined statement is then true or false. So specifically here, let's say we have a diagram, and then we have A and B over in the one column. So this satisfies our rule, or rather our statement, that if A is in box 1, that A is in box 1 and B is in box 1. So these two elements are joined by and, they both have to be true. So it both has to be true that A is in box 1 and it has to be true that B is in box 1. That means that this combined statement, A is in box 1 and B is in box 1, is true. Now, excuse me, if either of them is not true, if either A is not in box 1 or B is not in box 1, then the combined statement itself is not true. This is just what and means. And once again, this is fairly intuitive. This is the way we use it in everyday speech. So if we have a situation, we're drawing our diagram, we've got A in 1, but we've got B in 2, then we know that that's false. If we're drawing a diagram and it ends up where B is in 1 and A is in 2, we know that's false as well. Likewise, if they're both in, excuse me, if they're both over in 2, then we know that that is false as well. So it's not true that A is in box 1 and B is in box 1 if they're both over on the right or if they're split up. Okay, so that's what and tells us. Now, or is slightly different from the everyday meaning of the word or. So here we've got over on the right, A is in box 1 or B is in box 1, and the everyday meaning implies that only one of the two or more, if it depends how many things you're joining, but usually it's just two. So only one of the two elements is true. That's what or means. So when you say A is in box 1 or B is in box 1, then only one of those is true. That's what's called an exclusive or. So you would have a diagram like this. So you would have A in 1 and B in 2. Well, if we're saying that A is in box 1 or B is in box 1, then this would be true because A is in box 1. One of the two of them has to be true. So if this diagram works. Likewise, if we switch that around, if it turns out that we have B over in 1 and A is in 2, then it's true that A is in box 1 or B is in box 1 because one of them is there, meaning that B is in 1. However, on the LSAT, the meaning of or is that at least one of those elements is true, which means you can have a situation where they're all true. That's what at least one means. So when we read A is in box 1 or B is in box 1, it doesn't mean that only one of them has to be in box 1. You can have a situation where they're both in box 1. Now, this is very difficult. This is initially strange for a lot of students because it's counterintuitive for how we use or. For us, or implies you can't have both. What you have to remember is that on the LSAT, the or does not imply that. The or implies and maybe both. So A is in box 1 or B is in box 1, and maybe they both are. So all three of these diagrams are satisfy this statement above, that A is in box 1 or B is in box 1, because we have A in box 1 over in the top left, we have B in box 1 in the top right, and then we have both A and B over in 1 in the bottom left. So this is a situation. This is what or means. When you see or and you're looking to see does your diagram fit, and you have the diagram like the one in the bottom left, you know that that satisfies that statement, or usually it's going to be a rule, satisfies the rule that A is in box 1 or B is in box 1. So It's important that at least one of them is true. If none of them are true, then you know that the combined statement isn't true. So the A is in box 1 or B1 is in box 1. So if you've got something where they're both over on the right, you know that that statement's not true, because your rule says A is in box 1 or B is in box 1. If you have them both on the right, then that's not true, because you need to have at least one, but also maybe both. Okay, so that's what or means. Now you can actually negate these. So we have this statement that says A is in box 1 and B is in box 1. Well, what is the negation of that? Or rather, what does it mean when you can negate them? Well, when you negate an and statement, you're saying that their combination is false. Because remember, this is what and means. And means that you've just got both of these things are true. So if it's true that A is in box 1 and B is in box 1, then your diagram, they're both going to be there. But if you're negating that statement, if you're saying it's not true that A is in box 1 and B is in box 1, you're saying they're not together over on the left. But what does that mean? Well, that maybe they're both false. Maybe they're both on the right. So if you're saying that it's not true that A is in box 1 and B is in box 1, what you're saying is they're both on the right. But that's one possibility. Maybe only one of them is false. So maybe you've got a situation where you've got B in 1 and A in 2, or vice versa, A in 1 and B in 2. That is also a situation where it's not true that A is in box 1 and B is in box 1, because they're not together. Because remember, and also means together. Okay, so what that means is that one is false or the other is false. And this is very important when you kind of summarize it like that. If you're saying that it's not true that A is in box 1 and B is in box 1, well, maybe A is in box 2, or B is in box 2, or they're both in box 2. So maybe one or the other or both is false, and that's actually captured by the or. So you can rephrase that as, instead of saying A is in box 1 and B is in box 1, the whole thing crossed out, if you needed to negate that, you would be able to write A is not in box 1 or B is not in box 1. Those two mean the exact same thing. The reason they mean that is because of what or means and because of what and means. So when you're saying that A is in box 1 and B is in box 1, and then you're saying that's not true, you're saying that they're not both together on the left, which means that they might be on the right or they might be split up. Well, them being on the right or being split up is the same thing as saying that maybe A is not in box 1 or maybe B is not in box 1, because maybe they're split up or maybe they're both on the right. And the reason I'm bringing this up is because it's going to generally be easier if you have to negate a statement, and there's going to be situations where you have to negate statements depending on the question, depending on the rule, etc. So if there's a situation, we'll cover that in a lot of detail when we get to those situations. So if there's a situation where you have to negate something, it's generally easier to negate the elements individually than the whole statement, because then you have to do the actual translation in your head if you have the whole thing negated. Okay, so that's the situation with negating an and statement. But if you've got an or statement, so we have here A is in box 1 or B is in box 1, if you negate that, then when you negate an or statement, you're saying that none of the individual elements are true. Because remember, A is in box 1 or B is in box 1, at least one of those has to be true in order for that combination as a whole to be true. You got to have A in 1 or you got to have a B in 1. Remember, or means potentially both. But if you're saying that it's not true that one or the other is true, then they're both false. That there's no way that they're both false. And what you have here is there's no way that you can have them split up, A, B, B, A, or both over on the left. A is in box 1 or B is in box 1 is also satisfied if they're both on the left. So you're saying that none of those situations are true. And this is because, once again, or means that at least one is true. So it's at least one on the left, one on the right, flipped, that's flipped, or they're both on the left. So the only possibility, if it's not true that A is in 1 or B is in 1, is that neither of them is in 1. They're both in 2. Okay? And so the way you think about it is one is false and the other is false. So once again, we're taking the or and turning it to the and, like we did in the previous one, and turns into or. And you translate the statement above, A is in box 1 or B is in box 1, the whole thing crossed out. You translate it as A is not in box 1 and B is not in box 1. And once again, the logic is the same. If you have a statement where multiple things are joined by or, what that statement tells you is that at least one of those things has to be true. Now, if you're saying that that whole statement is false, that none of those things joined by or, it's not the case that at least one of them is true. That means that none of them are true. That's why you can check when you negate each element individually, you change the or into an and. And in fact, you can do that mechanically. So when negating a statement with an and or connectors, you're negating each element and you're negating the connector. So and becomes or when negated and vice versa. So we have this statement, A is in box 1 and B is in box 1, and then the whole thing is crossed out. So this sentence basically says it's not true that A is in box 1 and B is in box 1. Well, how can you rephrase it so it's a little bit more, so it's a little bit easier to work with? Well, and this is what I said by where you negate all the elements individually. Well, what you do is you take the first one. So A is in box 1. That becomes A is in box 1 by itself crossed out. Now the and becomes or, and then B is in box 1 is also individually crossed out. So these two things mean the same thing. If it's not true that A is in box 1 and B is in box 1, what that means is it's not true that A is in box 1, or it's not true that B is in box 1. Because remember, and means together. So you're saying they're not together in box 1. Well, maybe only one of them is, or maybe they're both on the right. Likewise, if you start with or. So if you've got a statement that says A is in box 1 or B is in box 1, well, once again, what you're saying is one of them's got to be in box 1, but you're negating that, so you're saying it's not true that one of them is in box 1. Well, what you're saying is that it's not true that A is in box 1. Change the or into and it's not true that B is in box 1. Same thing. So these statements all mean the same. Well, the statements and their translations below mean the same thing. So if A is in box 1 and B is in box 1, that is, you can say the same exact thing by saying, or rather, A is in box 1 and B is box 1 crossed out. You say that you could the same thing. You could say the same thing by saying A is in box 1 crossed out or B is in box 1 crossed out. The same thing here. You've got the whole thing crossed out, joined by or. You split it up into its elements, cross them out individually, and change the or into and. And that's how you work with and or with respect to combining different statements on the test. And then we'll see in future lessons how that, what the relevance of that is for the way that this information is expressed in the questions, the choices on the test. So to quickly summarize, statements can be connected via and or connectors. If a statement is connected with and, that means that all of the elements are true. And if a statement is negated, it means one or more elements aren't true. If a statement is connected with or, that means that at least one element is true, and maybe both, or maybe all. And if the statement as a whole is negated, that means that none of those elements are true.